What if we knew the exact date of 3I Atlas striking Earth? Just imagine, you wake up, check your phone, and see the very day the world will end. This is not science, not prophecy. It is a simulation, and it may disturb you. It's a way to feel what it might be like if the sky itself gave us a countdown. Subscribe to the channel, and let's begin. You wake up to the buzz of your phone. At first, it feels like any other morning, but when you roll over and reach for the screen, the headline freezes you. They finally gave the date, not an estimate, not a vague window, a day, a month, a year. The moment when 3I Atlas will strike. You stare at the words so long they blur. Part of you waits for the screen to flicker, for the letters to rearrange into something else, a prank, a glitch, a headline torn from a tabloid. But it doesn't change. Confirmed trajectory, impact probability, global event. Your first reaction is laughter, a short, nervous sound, half breath and half denial. It feels absurd, like something from a late-night disaster movie. You scroll through your feed and see you're not the only one. Memes are already everywhere. Cartoons of dinosaurs, smoking cigarettes under a fiery sky, jokes about the end of the world sale, videos of people pretending to check their calendars and cancel future appointments. You laugh again, but it doesn't stick. No one else is awake yet. It's just you and the slow churn of a coffee machine in the corner. The coffee tastes wrong, not bitter, not sweet, just metallic. The walls seem closer. Even the air feels thicker. You glance towards the calendar on the wall. Dentist appointments, birthdays, a vacation penciled in for the summer. Suddenly the notes look fragile, meaningless like promises written on tissue paper. Your eyes drift to the blank square in the future where the date belongs. Part of you wants to circle it, to mark the day in red, and face it directly. Another part recoils, because once the circle is there, every glance becomes a countdown. Your kid wanders into the kitchen. Why did the sky look funny? You freeze. Do you smile and dismiss it? Call it nothing, just clouds? Or do you say what no parent should ever have to say, that one day, too soon, the sky itself will fall? You settle for silence, a nod, a hand on the shoulder. But kids are sharper than we admit. When they leave the room, you sit alone again. And in that stillness, a thought pushes its way in. Unwelcome, but unstoppable. What would it look like? A flash in the sky, brighter than any sunrise. A wall of air rushing faster than sound. Streets cracking, buildings tumbling, voices silenced in an instant. You picture standing in your own driveway, watching the sky ignite as if the atmosphere itself had caught fire. For a heartbeat, you can almost feel the heat, smell the sharp tang of metal, hear the roar that swallows everything. Then you blink, and the kitchen is still. The mug sits untouched. The calendar is unchanged. Nothing has happened, not yet. You shake your head, pushing the vision away. But the ghost of it clings to you. It clings to the taste of the coffee, the weight of the silence, the sound of your young one's question hanging in the air. On your phone, the jokes keep coming. Someone posts a video of a man crossing off every day on a calendar with exaggerated sighs. Another draws a mock invitation. End of the world party, BYOB. The comment section fills with laughing emojis, but between the jokes, darker posts slip in. Screenshots of the official statement, words underlined in red. Impact confirmed. People ask, is this real? How can they know? Others answer with links, diagrams, charts. The voices clash, louder with every hour. You close the app, but the silence that returns isn't comfort. It's worse. It feels like the moment after laughter at a funeral, when the sound dies and everyone remembers why they're there. The morning continues. The clock ticks forward, indifferent. You force yourself to move through the motions, dishes, laundry, the thousand small things that make up a life. But each one feels thinner, drained of weight, like a play performed on a stage where the set is already burning. And every time your eyes stray to the calendar, the empty square waits for you. You try to convince yourself it will fade, that the world will scroll past it, laugh a little longer, and move on to the next story. Maybe by next week, the headline will be buried under politics, scandals, sports scores. Maybe you'll wake up one morning and no one will be talking about 3i Atlas anymore. But the story doesn't fade. It grows. It spreads into every conversation, every screen, every whisper overheard on the street. Then one evening, the government confirms it on live television. A date, a time, not a rumor, not a theory, a schedule. The broadcast begins with calm music, the kind they use to soften bad news. Anchors smile too widely. Their words are smooth, rehearsed, almost soothing. They speak of probabilities, of confidence intervals, of international cooperation. The words are chosen to be gentle, but their eyes betray them. Too wide, too careful. And when the word impact finally slips from their lips, their voices tremble. The screen cuts to scientists, men and women behind podiums, adjusting glasses, flipping papers, pointing to glowing charts. You expect reassurance, but the numbers only hollow you out further, 5 kilometers wide. You whisper the words as they appear on the screen. At first, the number feels small. You could walk that distance in an hour. But then the scientists explain. Mass measured in billions of tons. Velocity 60 kilometers per second. You imagine that speed, that weight, and the number stops feeling like math. It starts to feel like doom. The presentation continues. They speak of the orbit, of eccentricity greater than 1, of a hyperbolic path that promised a safe departure, until new data shifted the line. They remind the public of past visitors, Oumuamua in 2017, Borisov in 2019. Both passed harmlessly, curiosities rather than threats. This one is different. This one has a date. The anchor returns to the screen, whisper steady but pale. Impact probability exceeds 99%. Current trajectory cannot guarantee a miss. Preparations are underway. On the streets, whispers harden into certainty. A neighbor stands in his driveway, phone in hand, muttering that bunkers are already being built. But there won't be room for everyone. Someone else asks if it's better to stay above ground, to die in the light rather than in a hole. At the grocery store, people move slower, carts half filled, eyes flicking constantly to the TVs mounted above the checkout lanes. Cashiers scan in stillness, sneaking glances at the looping images of observatories and glowing arcs of orbits. The air inside feels heavy, like the store itself is holding its breath. Back home, you tuck your children into bed. They've seen the headlines too, heard the words repeated by teachers who couldn't keep the fear from their voice. Is it true? They ask. Do we really only have a few years? Are we on the list for the shelters? You smooth the blanket, kiss their foreheads, and force a smile. You tell them stories about birthdays and vacations, things they may never see. They listen quietly, but their eyes never stop searching your face. Children always notice what you're trying to hide. Later, lying awake in the dark, the house feels different. Every creak, every hum of the refrigerator is sharper, louder. You stare at the ceiling, replaying the broadcast in your mind. The graphs, the numbers, the confident words. the red line that refused to bend away. You want to believe they'll fix it, that humanity will find a way. But the thought won't leave you. If the date is written in the stars, then maybe nothing can erase it. The next wave of news doesn't bring comfort. It brings promises. Officials step up to podiums, their voices calm, words slippery. They speak of rescue programs, of emergency infrastructure, of survival strategies. Every phrase sounds polished, rehearsed, designed to soothe. But when you listen closely, the promises dissolve. They never say everyone. They say evacuation options. They say underground facilities. They say selective survival. That phrase lingers like a taste you can't wash away. Selective survival. You don't need them to explain. Some people will be chosen, most won't. Whispers sharpen into arguments. Who decides? The richest, the most powerful, scientists, soldiers, children. A man on the corner swears he's already paid for a place in a private shelter deep under the mountains. He brags about reinforced walls, filtered air, years of supplies. Another whisper cuts him down. No bunker can save you from the sky itself. At night, the news shows footage of construction sites. Vast machines bite into deserts and mountains, drills chewing through stone, cranes lowering steel into holes. The cameras pan wide, showing progress, industry, determination. They tell you it's proof humanity is preparing. But the lens never lingers on the entrances, doors too small, tunnels too narrow. Watching them, you can't escape the thought. These places were never meant to hold everyone. They're lifeboats with too few seats. And then you hear the numbers. A leaked report circulates online, whispered first in forums and then on the news itself. The shelters under construction, even if finished, would hold at most a few 100,000 people, perhaps 1 million, if crammed. You picture that number against the billions alive on Earth. A lifeboat for 1 in 10,000, less than the population of a single city. At the grocery store, the change is visible. Shelves thin out. People buy differently now, not fresh fruit or bread, but things that last. Cans, jars, bottles of water. A woman counts each can twice before putting it into her basket. A man clutches batteries as though they were gold. The checkout lines are silent. No one makes small talk anymore. At work, the atmosphere is worse. Desks are occupied, screens glow, keyboards clatter. But every conversation slips back to the same subject. Someone insists they've got a cousin in the military who knows the real list of names. Another swears the rich are already shipping families underground. An older colleague just shakes his head and says nothing, his silence heavier than words. Back home, the conversations shift too. Your partner asks, half in a whisper, if you should start storing supplies, if you should build something, even a small shelter. You hear yourself saying the practical things, where to put it, what it would cost. But underneath the words is the knowledge that no basement, no garage, no improvised bunker could stand against a comet 5 kilometers wide, moving faster than sound. And still, the idea claws at you. You imagine yourself digging, hammering, building, sealing. You imagine crouching underground while the sky tears open above. The thought is absurd. Walls of concrete and wood holding back a piece of the universe. Yet you catch yourself calculating how much food you could fit in the pantry. On the evening news, smiling anchors show maps dotted with new projects. Mountains hollowed out, old mines refitted, military silos converted. The words are full of confidence. Humanity prepares. Technology rises to the challenge. But the images tell a different story. Workers bent under floodlights, machinery grinding day and night. A desperate race against the stars. That night you can't sleep. You wonder, if there really is a lifeboat being built, will your name be on the list? And if it isn't? You notice the change first in the streets. Greetings, jokes, idle chatter now sharpen into arguments. From open windows spill fragments of debate, half shouted, half pleading. One side insists the government is exaggerating, that 3i Atlas will pass safely. The other whispers the opposite, that it's worse than officials admit, that the real calculations are hidden. In the city square, the arguments take shape. Protest signs rise above the crowd, some demanding truth, others demanding salvation. The shelters are for everyone, no one left behind. The chants echo against concrete walls louder than traffic. The air feels charged. But not all gatherings look like protests. Across town, people gather for something quieter. Hundreds kneel together under the crimson-tinted sky, their hands clasped, their words low. They don't call it a comet. They don't call it Atlas. They call it the messenger, a sign, a warning, a god. Candles flicker along sidewalks, pools of wax dripping onto pavement. Sermons spread through loudspeakers and voices raw with conviction. Some promise redemption if humanity repents. Others whisper of chosen survivors, not in bunkers, but lifted away by the hand of whatever sent Atlas here. Self-proclaimed prophets walk among them, dressed in rags or white robes, holding signs that say, "Prepare," and the sky has spoken. Workplaces fracture. Productivity dissolves. A report half finished stays half finished. Meetings drift off topic, collapsing into speculation. A manager snaps that work must continue, but even his whisper wavers. His own calendar has the date circled in red. Schools remain open too, but classrooms change. Kids stare at the sky through windows instead of at the board. Some teachers try to carry on, teaching math, history, grammar. Others give up and sit with students in silence, pretending to discuss literature while their eyes flick back to the horizon. The routine of the world continues, but it feels brittle. Supermarkets stock shelves. Trains arrive on schedule. Television shows still air in the evening, but under the surface everything quivers. Life hasn't collapsed yet. Instead, it frays thread by thread, as if the fabric of society is unraveling quietly in the background. On buses and trains, the tension is visible. Strangers avoid eye contact. Conversations drop when a new headline flashes on a passenger's phone. A few shops close altogether, paper signs taped to doors, closed indefinitely. And yet, not everyone succumbs. A group of young people laugh too loudly in a diner booth, insisting they'll throw an end-of-the-world festival. A couple on a park bench argue about vacation plans, determined to pretend life is unchanged. Their voices sound forced, brittle, but the act itself feels like defiance. Meanwhile, new groups form. Neighborhood meetings swell into movements. Some demand fairness, equal access to shelters, transparency in who will be saved. Others take darker turns, militias arming themselves, convinced the bunkers must be seized by force. Flyers appear on lampposts, scrawled with slogans about taking survival into our own hands. You walk past one of those lampposts at dusk, the paper fluttering in the wind, and realize something terrifying. People aren't waiting anymore. They're choosing sides, and the comet hasn't even arrived. That night, lying in bed, you picture what it might look like if society fractures before the impact. Streets burning, governments paralyzed, survival reduced to whoever holds the most weapons. You see a world that never makes it to the date circled on the calendar, not because 3i Atlas struck early, but because people tore each other apart first. And you ask yourself, if humanity collapses on its own, what difference will the comet even make? The next wave of headlines arrives with steel in its voice. No more whispers, no more vague promises. Now the words are sharp. Defense initiatives, interception missions, global response. On your screen, sleek animations show rockets streaking into the sky, warheads flaring bright against the black. The simulations are clean, clinical, almost beautiful. A comet the size of a mountain drifts toward Earth. Dotted lines arc toward it, explosions bloom, and the glowing rock drifts harmlessly aside. For a moment, you almost believe it. The images are convincing, the words calm. Anchors talk of planetary defense strategies and unprecedented cooperation. Scientists nod solemnly, standing before charts glowing in blue and red. Then the numbers return, and belief falters. 5 kilometers across. You could walk that distance in an hour, but a body of ice and stone that size, moving at 60 kilometers per second, carries energy greater than millions of nuclear weapons. You read it once years ago. The asteroid that ended the dinosaurs was roughly the same size. Chicxulub, 66 million years ago. The scar of it still lies buried beneath Mexico's Yucatan Peninsula. Now another scar waits to be written. The scientists do not say this directly. They talk instead of probabilities, of delta V, of kinetic impactors. They show graphs of launch windows, precise seconds where a rocket could strike the comet and nudge it by fractions of a degree. They speak of nuclear devices detonated at a distance, pushing with radiation pressure instead of shattering it. The language is elegant, technical, almost soothing. But you hear the undercurrent. They are not describing certainty. They are describing prayers disguised as equations. At night, a special broadcast fills the airwaves. Heads of space agencies speak with grave confidence. They explain that international teams are building interceptors, machines that will launch not years from now, but soon. They say humanity will not sit idle beneath the stars. The audience applauds. Hashtags surge across social media. Deflect Atlas, one world, we will survive. But in the silence that followed, doubts spread. Someone leaks a document showing that even a successful deflection requires flawless timing. If one rocket misfires, if one sensor fails, the attempt could fracture the nucleus instead of pushing it. 100 smaller impacts instead of one. Some scientists argue that would be worse. Your mind drifts back to the images, not the animations, but the real photos. The grainy telescope shots of 3 Atlas, glowing faintly red against black space. Its coma stretching nearly 700,000 kilometers, half the width of the sun, larger than anything Earth has ever seen up close. A storm of dust and frozen gas so vast, it makes the moon's orbit look small. How do you move something that breathes out an atmosphere larger than planets? How do you argue with a body older than the sun itself? 14 billion years drifting in stillness, now aimed at your home. And yet, people cling to the hope. Engineers work double shifts. Factories pivot overnight to build components. Students volunteer for research programs, hoping their work will tip the scale by the smallest fraction. The idea of fighting back takes root, fierce and desperate. At your workplace, the mood shifts. Conversations that once circled bunkers now buzz with technical jargon borrowed from the news. People argue about delta V values and intercept angles as though repeating the words could make them real. Charts and diagrams print out on office copiers, pinned to cubicle walls. Numbers become talismans, equations whispered like prayers. Even in your own mind, doubt and hope wrestle. You imagine the launch, a white flare against the dawn, humanity's hand raised against the ancient traveler. You picture the interceptors flying true, detonating at the perfect moment, 3i Atlas shifting just enough to slide past Earth. The planet saved, the date erased. Then the other image intrudes. The rockets fail. The blast shatters the nucleus. The fragments rain down. Smaller, yes, but dozens, hundreds. Oceans boil. Forests burn. Cities vanish. 100 Chicxulubs rewriting the sky. The broadcasts never show that image, but you see it anyway. And late at night, staring out the window at the faint red glow smearing the heavens, you wonder, are these missions salvation, or are they humanity's way of pretending we still have control? Time changes after the announcement. It no longer flows. It counts. Every conversation you overhear carries numbers in it. Not birthdays, not deadlines, not holidays. Just how many remain. A neighbor leans over the fence and mutters, 37 months. At first you think he means alone, or the time until retirement. Then you realize he's talking about the comet, counting down the months as if they were bullets in a chamber. The calendar on your wall takes on new weight. Dentist appointments, anniversaries, events. All of it looks like graffiti against the blank space waiting at the end. Crossing off days becomes a ritual, not just for you, but for everyone. Social media fills with images of marked calendars. Adults measure in numbers and months, but children think in celebrations. They don't ask about 37 months. They ask if there will still be Christmas, if there will still be birthdays. The questions land heavier than any headline. How do you answer? Do you promise yes, knowing you may be lying? Or do you admit that the sky has already claimed the calendar, that human holidays mean nothing to a body older than the sun? Teachers still plan lessons, but students count days on the margins of notebooks. Some cross them out methodically. Others decorate them with stars and drawings, as though trying to tame the fear with crayons. One teacher tells the class, there will always be time for learning. Your workplace is no different. Colleagues mutter about launch schedules for the intercept missions, about probabilities shifting by decimals. Yet, their eyes keep straying to the clock. Even in your own home, rituals shift. Dinner conversations begin with silence, end with counting. Beyond the home, the change is everywhere. Subway stations are quieter. Billboards once selling clothes, shoes, and vacations now display stark government slogans. Stay calm. Prepare. A new one flashes above the highway. There is still time. The words are meant to soothe, but the effect is the opposite. In cafes, people write in notebooks. Not shopping lists, not work notes, but journals, records of their days, letters to children, confessions they no longer want to keep inside. Some embrace the countdown differently. Online forums bloom with last wish lists. Strangers trade ideas. The books they'll finally read, the trips they'll take, the apologies they'll make before the date arrives. Others vow to ignore it entirely, to delete the apps, to live as though the numbers don't exist. But even that act of denial is shaped by the countdown. Late one night, you sit at the kitchen table with the calendar spread before you. You imagine tearing the page away, hiding it in a drawer, pretending the future is blank again. But the thought feels childish. The sky itself has already circled the date in fire. You close your eyes and picture the years ahead, each season framed as the last of its kind. One more summer by the lake, one more autumn of falling leaves, one more winter where frost clings to windows. The weight of that thought is crushing, but also strangely tender. You want to hold on tighter, to every hour, every sunrise, even as each one pulls you closer to the end. And you wonder, is it better to know? To cross each day off like a prisoner marking the wall of a cell? Or would ignorance have been a gift, living freely, never knowing the moment when the world would end? The waiting becomes its own kind of torture. Days are bearable, nights are not. In daylight, the noise of the world disguises the dread. Cars still move, voices still carry, screens still glow. But when darkness falls, the silence deepens. You wake in the middle of the night, not from sound, but from the absence of it. No cars, no birds, not even the rustle of wind. Just stillness, as though the entire world is holding its breath. Dreams become warnings. In one, you see 3i Atlas glowing above the horizon, larger than the moon, bleeding light into the sky. In another, it isn't just a shape, but something darker, heavy, watchful, patient. You wake sweating, heart pounding, only to find the red haze still glowing faintly through the blinds, as if the dream had followed you back into waking life. You begin to notice the same exhaustion in others. Neighbors with dark circles beneath their eyes, colleagues yawning through meetings, unable to mask their fatigue. It seems no one sleeps deeply anymore. Humanity has become a planet of light sleepers, waiting for the final alarm. Psychologists appear on news segments, their voices calm, suggesting routines. Avoid screens before bed, drink warm milk, practice meditation. The advice sounds laughable when set against a comet 5 kilometers wide. What comfort could breathing exercises bring when the sky itself is counting down above you? Even doctors begin to measure the toll. Hospitals report rising cases of insomnia, anxiety attacks, sudden heart problems. Patients come in not because they are sick, but because they cannot rest. Nurses whisper that medicine can ease symptoms, but nothing cures anticipation. Cities change after dark. Streets empty earlier, as though curfews have been written into the air without law. Lights in windows burn later, restless households awake together in silence. Some cities host night vigils, crowds standing in open squares, heads tilted back, staring at the faint shimmer above. No speeches, no music, just a silent gathering under the glow of inevitability. Conversations shift too. People no longer ask if the comet will hit. They ask what it will feel like. Some imagine a blinding flash, heat greater than fire, a shockwave tearing through cities before a thought could form. Others imagine the slower consequence, smoke choking the sky, fields freezing, years of cold where nothing grows. At night, your own mind spins those pictures against your will. You picture standing in your driveway, the air suddenly too bright, shadows folding in unnatural directions. You imagine the air itself rushing away, your lungs empty before you can scream. Another night you imagine the opposite, the days after, gray and endless, families huddled by fires, crops rotting under frost. Which is worse, to vanish in an instant or to linger in a hollowed world? The waiting gnaws deeper than either image. The strike itself might be quick, final. Waiting stretches every second into a blade. Even laughter carries weight now, a defiance against stillness rather than joy. Your kids sense the difference. They ask not when, but how. Will it hurt? Will we see it coming? And sometimes, in the deepest hours, you catch yourself asking the forbidden question, would it be easier not to know? To wake one morning and see the sky ignite without warning, instead of living through this slow erosion of certainty? Radios murmur the same words in every home. Updates, analysis, countdowns. You imagine each family lying awake, listening to the same words, hearing the same ticking clock. That night lying in bed, You imagine the very last night of all. Not the impact itself, not the fire or the roar, but the silence before it. A silence so heavy that even your own heartbeat feels intrusive. A world silenced not by fear, but by humility. You wonder if people will try to sleep through it, or if every eye on earth will remain open, waiting for the sound that will never let them close again. The months slip by and the world begins to look less alive. Not dead, not yet, but thinner, quieter, like paint fading on a canvas. Shops remain open, though their shelves look uneven. Some aisles are stripped bare, others cluttered with things no one bothers buying anymore. Batteries and bottled water vanish as soon as they arrive. Families start gathering more often. Dinners stretch into hours, though the food grows simpler. Old board games reappear. Photo albums are pulled from closets. Stories are told that once would have been saved for weddings or funerals. The act of sharing them now feels urgent, like passing on fragments of memory before the sky claims them. Letters multiply. People write to parents, children, siblings they haven't spoken to in years. Some are apologies, some confessions, some just a list of moments remembered with affection. A neighbor slips one into your mailbox by mistake. The envelope is thin, the handwriting shaking. You don't open it, but just holding it makes you feel the weight of lives trying to fit into a few final words. Schools transform. Teachers stop assigning long-term projects. Instead, they ask students to write journals to record how the world looks in its last seasons. Drawings line classroom walls, red skies, falling stars, families holding hands. Some children draw bunkers. Though the doors are always too small, the rooms too dark. Workplaces hollow out too. The rhythm of productivity collapses, replaced by farewell lunches and half-hearted meetings. People bring in pastries, not spreadsheets. Someone sets up a piano in the lobby of your office building, and soon strangers gather around it each day at noon. The music is clumsy, uneven, but no one cares. The sound feels like defiance, an echo of humanity insisting it is more than numbers on a countdown. Religions find resurgence. Churches glow with candlelight. Mosques and temples overflow with visitors who haven't stepped inside for decades. Sermons are spoken more softly now, less about doctrine, more about comfort. No one argues theology anymore. Faith itself has become a blanket, something to wrap around against the cold approach of the inevitable. Governments continue their speeches. More rockets are launched, more missions announced. But people no longer lean forward to listen. The broadcasts play in the background like distant weather reports. Hope, once sharp, now feels dulled, worn smooth by repetition. Most know the truth, even if they don't say it. The date has not moved. In the countryside, gestures of closure bloom. Farmers walk their fields one last time, hands brushing against wheat or corn as though saying goodbye. Some plant trees, knowing they will never see them grown. Others leave notes carved into bark, names, dates, prayers. The land becomes a kind of diary, a final message to anyone who might come after. You begin to notice the small changes in your own home. Drawers are emptied of clutter, closets thinned. Not because the things are needed elsewhere, but because the urge to simplify grows irresistible. You keep only what matters, as if the weight of unnecessary objects would be too much to carry into the final stretch. One evening, your family gathers in the living room. The lights are dim, the air heavy with unspoken words. Finally, someone suggests making a list. Not of chores, not of groceries, but of memories to create before the end. One more trip to the lake. A photo, together at the old house. A letter for the kids to open on their birthdays. The list grows not with grand ambitions, but with quiet, human things. And in that moment, you realize the strangest truth. Life in the shadow of 3i Atlas has become sharper. Every meal, every laugh, every hug feels magnified. The end has stolen the future, but in doing so, it has made the present unbearable in its intensity. As you lie in bed that night, staring at the ceiling, you imagine the comet drifting closer, indifferent to these small gestures of love and closure, and yet you cling to them, because maybe survival was never really the point. Maybe the real fight was to remember what it meant to live, even with a date carved into the sky. Transit schedules thin and then stop. Trains pull into stations and never leave again. A line of silent carriages turned into benches for people who don't want to be alone. Airport runways go dark one by one, red lamps extinguished not with drama, but with the click of a breaker somewhere in a silent room. Ships anchor just offshore. Crews allowed a final call home before the radios fall silent. Stores lock their doors, not with plywood or chains, but with small handwritten notes. Home with family. Back never. Libraries set out carts on the sidewalk and tell you to take whatever you want. A librarian presses a book into your hands and smiles in a way that makes you look away. Warm, tired, as if she's giving you a piece of her own past to carry the last few feet. Museums open for free and stop taking tickets. Guards lean against railings and whisper to each other while visitors move slowly through halls, pausing longer than usual at paintings they've seen 100 times. Cities invent new rituals in those last days. At dusk, some neighborhoods drag tables into the street and push them end to end, building a single long surface that runs the length of the block. Someone brings bread. Someone brings fruit that's a little bruised. Someone else sets down a cake. Strangers become less strange when you pass a plate from hand to hand. Small stories, soft laughter, the clink of cups in a world that finally stopped shouting. Elsewhere, people choose silent. Curtains close. Porch lights remain off. You pass houses where you know someone is home. Government broadcasts continue, but the voices have changed. No promises this time. Just information, measured and human. Where the last food distributions will be, which clinics remain open, when the grid will be stepped down. Someone has decided that, in the end, honesty is the only relief left to give. The announcer thanks the engineers by name. You find yourself whispering thank you back to a person who will never hear it. Pets become a subject no one prepared for. Shelters open their doors and stop asking questions. Children walk home hugging animals they've just met an hour before, already acting as if they've known them for years. In the park, you see a circle of people passing leashes to one another like torches, a simple compact. I'll make sure they're not alone. Work by then has shed the last of its pretense. Offices turn into lounges, then into living rooms. You look at pictures of company picnics and holiday parties from a decade ago and realize how little space those moments took and how much they hold now. On the second to last night, the city organizes something between a vigil and a festival. Not loud, never loud, but present. A projector shines old films against the side of a warehouse. People sit on blankets and watch flickering black and white faces fall in love, fail, try again. When the reel burns out and the image collapses into a white square, no one boos. They clap. For the film. For each other. For getting this far. Time, in those days, feels tall and thin. You become aware of the shape of a morning, the weight of a noon, the length of a single late afternoon that seems to last 3 times longer than it should. You start measuring in gestures instead of minutes. One more cup of tea, one more letter folded, One last time to stand at the window and watch the street fill with people you've learned by silhouette. You do things that would have seemed ridiculous a year ago and perfectly sensible now. You pack a small box not of essentials but of anchors, a photograph, a ribbon, a pebble from a beach you once visited and have no reason to keep except that your fingers know its shape. You record a message on your phone and delete it and record it again because you can't decide if the future deserves your voice or silence. What would you do with that day if you had it now? Would you join the neighbors at the long table and let your hands learn the weight of every offered bowl? Would you walk alone and memorize the way your street smells after a brief evening rain? Would you call the person you've avoided calling and say the one sentence you never sent in a message because writing it felt too permanent? Near the end, the world becomes kinder in small, exact ways. Drivers stop at crosswalks even when the lights are dead. People stand back and wave others through doorways. You didn't expect kindness to be the thing that breaks you. You thought it would be the broadcasts, the silent train stations, the empty runways. But it's the way a woman on the bus squeezes your hand once and lets go, then stares out the window with her jaw set, as if she just wanted to confirm you were real. The night before the end, you step outside and find the sky incredibly ordinary. No theatrical glow, no omen. Just a plain, clear dome with a few thin clouds moving like breath. Somewhere out there, beyond sight, is the reason everything has narrowed to a single point. You stand for a long time and try to memorize the exact temperature of the air, the texture of the sidewalk. There will be no tomorrow, only this last sunrise, and you are here to see it. Imagine a frozen traveler, small enough to cross on foot in under an hour, yet carrying the memory of billions of years. That's 3I Atlas, the newest interstellar visitor to slip quietly into our solar system. Its nucleus is tiny on cosmic scales, no more than 5.6 kilometers wide, about the size of a modest town you could drive across in 10 minutes. But wrapped around that small core is a ghostly atmosphere, or coma, hundreds of thousands of kilometers across. To picture it, imagine a pebble floating inside a bubble almost half as wide as the sun. The contrast is almost comical. A solid body smaller than many suburbs, surrounded by an atmosphere so enormous it could swallow Earth dozens of times over. And yet, that's exactly what we're seeing through telescopes right now. What makes Atlas truly extraordinary, though, isn't just the size of its coma. It's the age. Astronomers believe it formed billions of years ago, long before the sun existed, long before Earth ever had oceans or continents. In other words, this object may be older than our solar system itself, a time capsule of alien ice and rock, wandering for eons through the galaxy until, by chance, we noticed it. Think about that for a moment. A fragment of matter forged in a star system we'll never see, carrying the chemistry of an era when the Milky Way itself was young. And here it is drifting through our neighborhood for a brief visit. This is only the third interstellar object humanity has ever discovered. The first was Oumuamua in 2017, a cigar-shaped enigma that accelerated in ways we couldn't explain. The second was 2I Borisov in 2019, a comet that looked more familiar but still came from beyond the sun's grasp. And now comes 3I Atlas, spotted in July 2025 by the Asteroid Terrestrial Impact Last Alert System in Chile. 3 in total, that's it. Thousands of years of sky watching. And only in the last decade do we realize the galaxy occasionally tosses visitors our way. But Atlas is different. Unlike Oumuamua, which was discovered too late to study closely, or Borisov, which offered fewer surprises, this one arrived with timing on our side. We've caught it months before its closest approach, giving astronomers a rare window to examine an interstellar traveler in real time. And what they've already found defies expectations. Chemistry unlike any comet we've seen, activity beginning farther from the sun than usual, and signs that it may carry a record of environments very different from our own. For me, that's where this story stops being just astronomy and starts feeling personal. We measure our lives in decades, our history in centuries. 3I Atlas has been drifting for billions of years. It has survived supernovae, the slow churn of galactic arms, and countless encounters with stars we'll never name. Compared to that, the rise and fall of civilizations, including ours, barely registers. Oddly enough, that thought is comforting, because while our world can feel chaotic and fragile, the universe carries stories so much older, steadier, and calmer than ours. Atlas doesn't care about politics or headlines. It just drifts, as it always has. And tonight we get to drift alongside it. Before we continue, if you enjoy calm journeys into mysteries like this, consider subscribing. It takes only a second, and it helps me keep creating long, thoughtful stories, perfect to listen to as you fall asleep. Thanks for being here. Now, let's follow 3I Atlas together. Slowly, like two friends under a night sky, we'll explore what makes this small ancient traveler one of the most remarkable visitors humanity has ever known. The story of 3I Atlas begins on a quiet night in Chile, July 1st, 2025. At the Rio Hurtado Observatory, one of the 3I Atlas survey telescopes was doing what it always does, scanning the sky for anything that moves. 3I Atlas stands for Asteroid Terrestrial Impact Last Alert System, a global network designed to catch dangerous asteroids before they catch us. Its job is simple but vital. Take pictures of the sky every 30 seconds, compare them to earlier frames, and flag anything that shifts against the background of stars. Most of the time, it finds nothing more exciting than a faint asteroid or a piece of space junk. But that night, the software noticed something different. At 3:42 UTC, the telescope recorded a point of light moving faster than it should have. At first glance, it was just another dot among millions. But algorithms immediately flagged it as unusual. Its speed didn't match typical asteroids, and its brightness was changing in ways that looked strange. Within hours, follow-up checks confirmed this wasn't an error. It was real, and it was on a trajectory unlike anything in the asteroid catalog. That's when astronomers began to get excited. Using early observations, they calculated its orbit and found something extraordinary. The eccentricity, the measure of how stretched out an orbit is, was greater than 1. That number may sound dry, but it means something big. Anything with an eccentricity above 1 isn't bound to the sun. It's not looping around for another pass. It's just passing through, an interstellar visitor. The news traveled quickly. Within 6 hours, observatories in Hawaii and California confirmed the same moving object. The Minor Planet Center in Massachusetts, which serves as the world's clearinghouse for new discoveries, published early orbital elements, hyperbolic path, inbound from deep space. Just like that, humanity had its third confirmed interstellar object. What fascinates me about this moment is how quietly it happened. No fireworks, no dramatic countdown. Just a faint dot, picked up by an automated system, noticed first by a line of computer code. Humanity met its newest interstellar neighbor, not with a telescope aimed by hand, but with a network of machines patiently scanning the sky. In a way, it's poetic. While we sleep, our instruments keep watch. And sometimes, they catch something we never expected. Of course, the discovery didn't stay quiet for long. Once the word interstellar appeared in the Minor Planet Center's updates, astronomers around the world swung their telescopes toward it. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, even Hubble, and later the James Webb Space Telescope, all wanted a piece of this fleeting visitor. Time on those instruments is rare and expensive, but the chance to study an interstellar object, that's priceless. By July the 2nd, excitement had already spread beyond the scientific community. Oumuamua and Borisov had both captured public imagination, and now the headlines were back. A new interstellar comet detected. But what made this discovery even more thrilling was the timing. Oumuamua was spotted only after it had already passed the sun. Borisov gave us a little more notice, but still not much. 3 Atlas, on the other hand, was found months before its closest approach. That meant astronomers had time to plan, to gather data, to really learn something from it. And so, almost overnight, 3I Atlas became one of the most carefully watched objects in the sky. Its brightness, its spectrum, its shape, all of it went under the microscope. From the very first measurements, it was clear this wasn't a typical comet. The coma, rich in carbon dioxide, was unusual. The nucleus was small but active. And the trajectory, well, that told the real story. This wasn't one of ours. It came from beyond. There's something deeply human about this whole discovery. We build machines to look for threats to keep us safe. And in the process, those machines sometimes stumble across wonders. The 3I Atlas survey was designed to find rocks that might endanger Earth. Instead, it found an ancient traveler, older than Earth itself, drifting harmlessly past. A reminder that not every visitor is a threat. Some are just stories waiting to be told. When astronomers talk about 3I Atlas, the first numbers they bring up are speed and path. This comet isn't just visiting. It's racing through our solar system at extraordinary velocity. Near perihelion, its closest approach to the Sun on October 29, 2025, Atlas will be moving at about 68 kilometers per second. That's roughly 150,000 miles per hour. If you tried to put it in earthly terms, it's fast enough to fly from New York to Los Angeles in under 90 seconds. At that speed, Earth itself would seem tiny, a blur under its trajectory. Speed alone isn't unusual. Comets often move quickly as they fall toward the Sun. What sets 3I Atlas apart is its trajectory. Unlike most comets, which follow elongated ellipses that bring them back again and again, 3I Atlas follows a hyperbola. Its orbital eccentricity is about 1.7, well above the threshold of 1 that separates bound orbits from unbound ones. In plain English, that means it's not tied to the Sun at all. Once it swings past, it's gone, forever. No return ticket, no second chance, just one fleeting visit. That's what makes studying objects like this so urgent. With Oumuamua, we realized too late that it was already heading out. With Borisov, we got a little more time, but still not much. 3I Atlas gives us months of observation, yet once it's gone for good. These interstellar guests don't loop back every 75 years like Halley's Comet. They appear once in human history and vanish into the dark. The trajectory also tells us where 3I Atlas came from, or at least gives us hints. By tracing its path backward, astronomers conclude it originated from the galaxy's thick disk, an ancient population of stars, billions of years old. That fits with its likely age, somewhere between 7 and 11 billion years. Imagine an object formed before Earth even existed, wandering the galaxy for aeons, and now passing within our reach. It's a little like finding a fossil from a time before life began on our planet. On its way through our neighborhood, The 3i Atlas will pass near a few familiar worlds. On October 3rd, 2025, it will come within about 28 million kilometers of Mars, close enough that orbiting spacecraft may get unprecedented images. A month later, on November 3rd, it brushes by Venus at a distance of 97 million kilometers. For Earth, the closest approach comes later, on December 19th, 2025, at 1.8 astronomical units, about 270 million kilometers away. Safe for us, but close enough to track in detail with telescopes. And then it will be gone. By early 2026, 3i Atlas will fade into the distance, shrinking night by night until even our best instruments can no longer see it. It will accelerate back into interstellar space at a velocity of about 58 kilometers per second, carrying its secrets with it. In another few million years, it might pass another star, another planetary system, and maybe another civilization will wonder about its origin, just as we do now. There's something bittersweet about that. A visitor comes, stirs our curiosity, gives us a brief chance to look at the galaxy in a new way, and then disappears. We can't hold on to it. We can only observe, record, and imagine. Maybe that's part of the lesson. Some mysteries are meant to be glimpsed, not owned. 3i Atlas's trajectory reminds us how small we are in cosmic terms. We live on a planet bound tightly to the sun, circling in predictable paths. 3i Atlas is free. It belongs to no star, no system. It's a wanderer unchained, carrying the chemistry of a world we'll never see. And for just a little while, it's here with us. When astronomers realized 3i Atlas was moving too fast to belong to our solar system, the next question became obvious. Where did it come from? And how old is it? The answers are still uncertain, but the clues point to something extraordinary. This comet may have formed not just before Earth, not just before the Sun, but in an era when the Milky Way itself was still young. The key lies in its trajectory. By tracing 3i Atlas's path backward, astronomers can estimate its origin. The numbers suggest it comes from what's called the thick disk of our galaxy, a population of stars that formed billions of years ago. Unlike the younger, thinner disk where our sun resides, the thick disk is ancient, dating back 7 to 11 billion years. That makes 3i Atlas a relic of a galactic chapter long closed, a survivor from a time when star formation was more chaotic, and the chemical makeup of the galaxy was very different from today. How do we know this? Part of the answer comes from chemistry. Early spectroscopic data from the James Webb Space Telescope revealed a coma dominated by carbon dioxide, with a ratio of CO2 to water of roughly 8:1. That's almost unheard of in solar system comets, which are usually rich in water. This unusual fingerprint hints at a birthplace around a different kind of star, in conditions that no longer exist nearby. Combined with its high velocity and unbound orbit, the evidence builds toward one conclusion. 3i Atlas is ancient, formed far away, and shaped by physics we don't normally encounter close to home. Think about that number again. 7 to 11 billion years. Our sun is about 4.6 billion years old. Earth formed shortly after, and life took even longer to appear. In other words, 3i Atlas may have been wandering through the galaxy for twice the entire age of the solar system. To put it in perspective, when this comet solidified out of gas and dust, the sun had not yet begun to shine. Dinosaurs, humans, even Earth itself were still unimaginable. That kind of timescale is difficult for us to grasp. Human civilization measures history in thousands of years. Our species, Homo sapiens, has existed for maybe 3,000 years. 3i Atlas has been traveling for tens of thousands of times longer than that. to it, the rise and fall of civilizations would barely register. Our greatest monuments, our languages, even our species might pass into silence, while it continues drifting silently from one star system to the next. It's also a reminder of how violent the universe can be. Objects like 3I Atlas are thought to form in the early days of star systems, then get ejected by gravitational encounters with giant planets or passing stars. Most of these fragments are lost forever, tossed into interstellar space. 3I Atlas just happened to cross our path. That it has survived intact for billions of years through radiation, collisions, and galactic turbulence is almost a miracle. For scientists, the age of 3I Atlas is more than a curiosity. It's a rare opportunity. Studying it may let us peer into the chemical history of the galaxy itself. It carries, frozen in its ices, the fingerprints of a time before our sun was born. That's why telescopes around the world are focused on it now. It's not just a comet. It's a messenger from deep time. For me, the thought is both humbling and oddly comforting. We are so young compared to this visitor. Our worries and crises feel overwhelming. But here is an object that has seen billions of years pass without hurry, without fear. It has endured while stars were born and died, while galaxies evolved, while entire epochs faded into memory. And yet, for this brief moment, our paths have crossed. When you hear the word comet, you probably imagine a glowing streak across the night sky, a tail trailing behind like a cosmic brushstroke. But with 3I Atlas, what we're really looking at is something far stranger, a sealed container of ancient history. Every comet is, in a sense, a time capsule. Unlike planets, which recycle their material through volcanism, weather, and plate tectonics, comets remain mostly unchanged. They are frozen leftovers, fragments of the raw ingredients that built worlds. Studying them is like digging into the freezer section of the universe. You find the original recipe still intact. What makes 3I Atlas unique is the sheer age of its freezer. This object didn't form in our solar system's pantry. It formed in someone else's, billions of years before Earth existed. Locked within its ice are chemical clues to an alien environment, different temperatures, different radiation, perhaps even a different kind of star. The ratios of carbon dioxide, water, and trace elements aren't just random. They're fingerprints of a birthplace we can't visit, but can study through this fragment. Astronomers sometimes describe interstellar objects as samples we didn't have to fetch. Normally, to study the chemistry of another star system, we would need a probe capable of traveling light years, something well beyond our reach. But 3I Atlas came to us. It drifted for billions of years, carrying the frozen memory of its origin, and now it's within range of our telescopes. For planetary scientists, that's as close as magic gets. Think about what this means. Inside that small 5-kilometer nucleus are molecules that condensed before our sun was even born. They've been preserved through galactic journeys, shielded by cold and distance. When 3I Atlas releases gas into space, it's like uncorking a bottle from the earliest days of the galaxy. The vapor we measure now may carry the signature of an environment so old and so foreign that it forces us to rewrite parts of our textbooks. The James Webb Space Telescope has already picked up some of these signatures. The dominance of carbon dioxide over water is unusual enough to suggest that 3I Atlas formed in a region where CO2 ice was stable, but water ice wasn't. That alone implies a chemical environment very different from the one that shaped our comets. And then there are the hints of other molecules, carbon monoxide, sulfur compounds, even traces of nickel that add layers to the puzzle. Each detection is another piece of evidence about the kind of star and protoplanetary disk this comet once called home. It's humbling to realize how fragile this opportunity is. We have only a short window to study Atlas before it slips away forever. Once it's gone, the frozen memory it carries will continue, traveling into the void, unread by us, unreadable without the right instruments. We can only take notes now, while it's close, and hope those notes are enough to tell the story. I like to think of it as finding a letter in a bottle on a beach. The ocean carried it for ages, battered the glass, erased parts of the ink. But somehow, against all odds, it washed up at your feet. You may not be able to read every word, but what you can read connects you to someone far away, someone from another time. Atlas is that bottle, drifting not across seas but across the galaxy. Its message partly clear, partly smudged, but undeniably real. So as telescopes gather spectra and track its fading coma, we're not just collecting data. We're opening the galaxy's freezer and peeking at ingredients from a recipe written billions of years ago. What story they tell may change how we think about planetary systems, about star formation, about the diversity of worlds scattered through space. And while scientists debate ratios and origins, the rest of us can simply marvel. A piece of deep time has wandered into our skies. We don't need to own it. We just need to pay attention. Every comet carries a chemical story. In our solar system, that story usually begins with water. Most comets are made primarily of H2O ice, with smaller amounts of carbon dioxide, carbon monoxide, and a dusting of other molecules. That's what astronomers expect when they point their instruments at a glowing coma. But Atlas didn't follow the script. When the James Webb Space Telescope focused on 3I Atlas in August 2025, its near-infrared spectrograph recorded a result no one had predicted. Carbon dioxide dominated the spectrum. The ratio of CO2 to water was about 8:1. For context, comets in our solar system usually have the opposite balance, 10 to 100 parts water for every part of carbon dioxide. Even the driest known comets rarely exceed 2:1. 3I Atlas wasn't just unusual, it was in a category of its own. Hubble confirmed the nucleus was small, less than 5.6 kilometers, which made the outgassing even stranger. How could such a tiny object release so much carbon dioxide? NASA's SphereX mission added another twist. Its infrared mapping revealed the gas cloud extending nearly 700,000 kilometers in diameter. That's half the width of the sun, created by a nucleus smaller than many towns. A scale so disproportionate it borders on absurd. And the puzzle didn't end there. Different observatories reported conflicting signals about water. NASA's Swift mission detected hydroxyl radicals, indirect evidence of water vapor. Yet Webb and SphereX found the water signature faint, almost negligible. Was the water hiding beneath the surface, trapped under a crust? Or was it there but overwhelmed by the sheer abundance of CO2? The discrepancy remains unresolved. Other molecules deepened the mystery. Observers detected carbon monoxide, nickel, and sulfur compounds like carbonyl sulfide. Nickel is especially intriguing. It normally requires high heat to vaporize, suggesting unusual processes either in 3I Atlas's past or in the way solar radiation is interacting with it now. The sulfur chemistry hints at complex conditions in its birth environment, conditions that may have little resemblance to the sun's protoplanetary disk. For planetary scientists, these details aren't just trivia. They are fingerprints. Chemistry tells the story of origin. A comet dominated by CO2 might have formed beyond a carbon dioxide snowline, in a region cold enough for CO2 to freeze, but too warm for water ice to dominate. Alternatively, 3I Atlas could have formed in a volatile rich zone near a massive young star, where intense radiation stripped away water but left carbon dioxide intact. A third theory points to its long interstellar journey. Billions of years of cosmic rays could have reshaped the surface, creating a crust that allows CO2 to escape while trapping water below. Each scenario carries enormous implications. If 3I Atlas represents a typical interstellar comet, it means other planetary systems may produce bodies very different from our own. If instead it's a rare outlier, then we've stumbled upon a 1 in a billion fragment, a cosmic exception that challenges our assumptions. Either answer is valuable, and there's still more. Some astronomers suspect 3I Atlas may be fragmenting. Small pieces breaking off could expose fresh CO2-rich ice, fueling the giant coma. If true, that would explain why the gas cloud is so much larger than models predict. But if it's stable, then we may need entirely new physics to account for its activity. For me, the strangest part is that all of this is happening right now, and we only get a few short months to watch. After that, 3I Atlas will fade from view, carrying its unresolved chemistry back into the dark. We're left piecing together its story from a patchwork of observations. Webb's infrared spectra, Hubble's imaging, SphereX's wide-field maps, Swift's ultraviolet detections. Each instrument sees a part of the picture. None can see it all. That's why 3I Atlas is more than just a comet. It's a reminder that the universe is full of laboratories we didn't design, laboratories that appear without warning, stay briefly, and vanish forever. Its chemistry doesn't just tell us about itself. It tells us that we haven't seen the full range of what's possible, that the galaxy is richer, stranger, and more inventive than we ever assumed. One of the hardest parts about talking astronomy is scale. Numbers like kilometers and astronomical units don't always land. So let's put 3I Atlas into human terms and see how it compares to the worlds we know best, Earth and the Sun. Start with the nucleus. At no more than 5.6 kilometers across, it's smaller than many towns. You could drive across it in 10 minutes, or walk from one side to the other in under an hour. If 3I Atlas's nucleus were sitting on Earth, it would barely cover the area of a small city. Nothing like the vast continents and oceans we take for granted. By itself, the core is modest, almost unremarkable. Now zoom out. Surrounding that little city-sized core is a coma, a cloud of gas and dust stretching hundreds of thousands of kilometers across. At its peak, observations suggest the coma reached almost 700,000 kilometers in diameter. That's more than 50 times the size of Earth. If you placed Earth inside Atlas's coma, our entire planet would look like a marble floating in fog, swallowed without effort. And then there's the Sun. Our star is enormous, 1.39 million kilometers across. Compared to that, even Atlas's massive coma looks smaller, but not by much. Half the Sun's width, created by a core smaller than Manhattan. That's the part scientists still struggle to explain. How can something so tiny project an atmosphere on such a terrifying scale? Imagine it this way. Picture holding a pebble in your hand and seeing it surrounded by a balloon the size of a skyscraper. That's the kind of mismatch we're talking about. The comet's solid body is nearly insignificant, but its presence reshapes space around it in ways that make Earth look fragile by comparison. This contrast is part of what makes 3I Atlas so captivating. It challenges our instincts. We're used to thinking that size determines influence, that bigger things dominate smaller ones. 3I Atlas flips that idea upside down. A nucleus you could walk across casually creates a shroud so enormous it competes with stars. 3I Atlas casually throws out a cloud thousands of times thicker, without effort, without intention. It doesn't need engines or design. Just the heat of the sun is enough to unlock that scale. For me, this makes 3I Atlas feel less like an object and more like a metaphor. Small things can have enormous presence. A fragment of ancient ice smaller than a city can create an atmosphere so vast it rivals our star. If that doesn't remind us to keep perspective, I don't know what will. If 3I Atlas is truly billions of years old, then try to imagine what it has lived through. Not in the way a human sees, of course. Comets don't have memories. But by simply enduring, by carrying its frozen heart across time, Atlas has survived epochs that dwarf everything we know. Its likely birthplace was the thick disk of the Milky Way, a region populated by some of the oldest stars in our galaxy. When 3I Atlas first condensed out of dust and ice, heavy elements like carbon and oxygen were just beginning to spread widely, seeded by the explosions of massive stars. The galaxy was turbulent then, full of violent supernovae and bursts of radiation. Out of that storm, this small body emerged and was cast into interstellar space. From there, it began a journey measured not in centuries or millennia, but in galactic rotations. The Milky Way takes about 230 million years to complete one turn. 3I Atlas may have circled the galactic center dozens of times, threading through spiral arms rich with molecular clouds. Each arm is a nursery of star formation, where giant suns ignite and smaller stars like our own are born. 3I Atlas drifted through them as a silent witness, passing regions of light and shadow, gravity and chaos. Along the way, the galaxy itself changed shape. The central bar of the Milky Way grew more pronounced. Star clusters formed, lived, and dissolved. Entire generations of suns came and went, some leaving behind white dwarfs, others collapsing into neutron stars or black holes. 3I Atlas endured it all, too small to be noticed, too stubborn to be destroyed. It's possible that 3I Atlas passed near other planetary systems. Perhaps it skimmed the outskirts of alien Oort clouds, brushing past comets that belong to other suns. A few close stellar encounters may have tugged at its orbit, changing its course little by little until, by chance, it intersected ours. Each deflection was part of a long choreography, written not in years, but in billions of years. Meanwhile, on Earth, well, there was no Earth. The sun itself had not yet formed. When our solar system finally appeared 4.6 billion years ago, 3I Atlas had already been traveling for millennia beyond counting. By the time oceans filled our young planet, 3I Atlas was still drifting. By the time dinosaurs thundered across continents, 3I Atlas was still drifting. By the time humans struck their first sparks and painted on cave walls, 3I Atlas was still drifting. Always moving, never pausing, older than everything we know. That survival is remarkable. Cosmic rays, collisions with interstellar dust, and the faint drag of starlight, all could have eroded it into nothing. Yet the nucleus remains intact. It may be scarred, crusted, weathered by ages, but the core is still there, holding chemistry from a time when our galaxy was young. So when we look at 3I Atlas now, we're not just seeing a comet, we're seeing resilience, a fragment that endured when stars exploded, when spiral arms shifted, when galaxies around us collided and merged. 3I Atlas is living evidence of deep time, a messenger that says, yes, survival is possible even across billions of years. And after all that, it has found its way here. For the briefest instant in its unimaginably long history, This ancient wanderer crosses paths with us, tiny humans looking up with curiosity. We don't change its journey, but it changes ours, because for a moment, we can glimpse what it means to be truly old and to keep going. Every so often, astronomy forces us to confront the limits of perspective. We measure time in years, in birthdays, in generations. History books stretch back a few thousand years, maybe a little more. For most of us, that already feels vast. But when you stand next to 3I Atlas, even in imagination, those scales collapse. Suddenly, human history feels like a breath, a flicker in the dark. This comet has been drifting through space for billions of years. Long before the first human looked up at the night sky, before language, before fire, Atlas was already wandering. Long before Earth itself cooled into oceans and continents, it was on its way. To us, the entire story of civilization is overwhelming, full of triumphs and failures. To Atlas, if we can even speak that way, it is less than a blink. There's something oddly reassuring in that. When life feels chaotic, when news headlines pile up with urgency, it helps to remember that the universe carries stories older and steadier than ours. Atlas doesn't react to political storms or economic shifts. It doesn't care about our arguments or our ambitions. It drifts. Patient, indifferent, eternal on our scale of time. That perspective doesn't make our problems vanish, but it does put them in context. And yet, we can also flip the perspective. If Atlas has been traveling for billions of years only to cross our path now, then maybe our moment isn't so small after all. For all of human fragility, here we are. The first species on Earth capable of recognizing what Atlas is. The first to study it, to measure its chemistry, to wonder about its origin. Out of all the countless civilizations that might exist in the galaxy, we may be the first to truly notice this particular traveler. That too matters. I like to think of Atlas as a mirror. It doesn't show us anything about itself that we didn't already expect: ice, dust, gas. What it really reflects is how we respond. Do we see it as a threat, a distraction, a messenger, a mystery? Each interpretation says less about the comet and more about us. In that sense, Atlas is a test. It shows whether we can hold uncertainty without fear, whether we can let wonder exist without demanding simple answers. In philosophy, there's a tradition of using the night sky as a reminder of humility. The Stoics, the mystics, even poets across cultures, all looked up and found meaning in the stars. Atlas adds a new chapter to that tradition. It's not just a distant point of light. It's a visitor, a fragment of another world. It reminds us that we are not isolated. Our solar system is part of a much larger community, connected by these wandering messengers that occasionally pass through. So as we track Atlas across the sky, it's worth pausing for reflection. Maybe the most valuable thing this comet offers us isn't new chemistry or orbital mechanics, but perspective. A reminder that we are young, that our problems are temporary, and that even in the vastness of time and space, we can still find wonder. For astronomers, 3I Atlas isn't just an interesting visitor. It's a once-in-a-lifetime laboratory delivered straight to our doorstep by the galaxy itself. Normally, if we wanted to study the chemistry of another planetary system, we'd need to send probes across light years, something far beyond our capabilities. Atlas spares us that impossible journey. It carries material from a different star system directly into reach of our telescopes. That's why nearly every major observatory has turned its attention toward it. Hubble and the James Webb Space Telescope, the Very Large Telescope in Chile, Keck in Hawaii, all have dedicated precious time to studying Atlas while they can. This level of coordination is rare, reserved only for objects of the highest importance. It tells you just how valuable Atlas is. So what are scientists hoping to learn? First, the chemistry. By measuring the gases in its coma, we can compare Atlas to comets from our own solar system. Already we see it doesn't follow the same recipe. Understanding why can reshape our models of planetary formation. Do all star systems produce icy fragments like this? Or is Atlas an outlier? That's a question with implications far beyond comet science. Second, the physics. Atlas is unusually active for its size. Measuring how it vents gas and dust helps scientists test theories about how interstellar travel changes small bodies. Billions of years of radiation, dust impacts, and gravitational nudges must leave scars. Does the surface harden into a crust? Do ices migrate inward? Does a nucleus this small survive intact by chance, or is survival common? Each answer helps us see how matter evolves in deep space. Third, the population question. With only 3 interstellar objects confirmed so far, Oumuamua, Borisov, and Atlas, we don't know how common they truly are. Dozens may pass through every decade, unnoticed until recently. Improved surveys like Atlas, Pan-STARRS, and soon the Vera Rubin Observatory may reveal that these visitors are frequent. If so, we could prepare future missions to intercept them. Imagine a spacecraft waiting in orbit, ready to launch toward the next interstellar traveler. Atlas may be the rehearsal for a new era of exploration. To appreciate this, it helps to remember past missions. In 2014, the Rosetta spacecraft orbited Comet 67P Churyumov-Gerasimenko and even deployed a lander. That mission taught us how ordinary comets behave up close. Now Atlas offers a chance to compare. How does a comet from another star differ? Rosetta's data provides the baseline, Atlas the outlier. The contrast could be revolutionary. There are also proposals, ambitious but serious, to redirect spacecraft for close observation. NASA's Juno, currently orbiting Jupiter, has been suggested as a possible candidate. While such an intercept may not be feasible, the very fact that scientists are considering it shows how important Atlas is. If we could ever meet such an object up close, the payoff would be enormous. And then, there's the broader perspective. By studying Atlas, we test the universality of science itself. Does chemistry work the same way under alien conditions? Do planetary systems elsewhere produce familiar building blocks or entirely different ones? The answers may touch even the search for life. If Atlas's chemistry is wildly different, it could mean planets in its home system followed paths we haven't yet imagined. What excites me most is the possibility of surprises. Astronomy's history is full of them. Volcanoes on Io, geysers on Enceladus, complex atmospheres on Titan. Each discovery forced us to rewrite our expectations. Atlas may do the same. Maybe its chemistry reveals environments we never predicted. Maybe its activity points to processes we don't yet understand. The universe has a habit of exceeding imagination. That's why Atlas matters. It's not just a comet. It's a cosmic experiment, billions of years in the making, finally unfolding in front of us. We won't learn everything, but what we do learn will expand the edges of our knowledge. And perhaps, the next time an interstellar traveler passes by, we'll be ready not just to watch, but to go out and meet it. For all the excitement surrounding 3i Atlas, there's a frustrating truth. We may never fully understand it. The window to observe an interstellar visitor is painfully short, and every night counts. Atlas was discovered in July 2025. Its perihelion, the closest approach to the Sun, comes at the end of October. That sounds like plenty of time, but the geometry of the solar system works against us. As the comet nears the sun, it slips into the same patch of sky as our star. For nearly 6 weeks, from late September to early November, ground-based telescopes will be blinded. The very moment when Atlas is most active, venting gas, growing brighter, revealing its secrets, will coincide with its disappearance into solar glare. By the time it emerges again in December, it will already be fading. Even when the comet is visible, observing it is anything but simple. Its nucleus is no more than a few kilometers wide, impossible to resolve directly at distances of hundreds of millions of kilometers. What we see instead is the coma, a diffuse fog of gas and dust. That coma hides the nucleus, making it hard to know its shape, spin, or surface features. Astronomers can only place upper limits, smaller than 5.6 kilometers, dimmer than certain thresholds. Everything else is inference. Studying it is like trying to understand a candle by staring at the smoke. Speed adds another layer of difficulty. Atlas races through the sky faster than most known comets. Telescopes must track at unusual rates, sometimes pushing their mechanics to the limit. Long exposures blur into streaks, contaminating the data. Even the most advanced facilities like Keck or the VLT must take rapid-fire images, then use software to reconstruct the comet's motion. It's astronomy on a stopwatch. Algorithms help, but they aren't perfect. Automated pipelines sift through images, separating faint comet signals from background stars and cosmic noise. The crowded fields near the galactic center make this especially hard. Star trails overlap with the comet's own faint glow, and distinguishing between them can feel like trying to hear a whisper in a crowded room. Researchers often spend hours cleaning data by hand, frame by frame, knowing that each night of usable information could be the last. Then comes the challenge of interpretation. Different instruments report slightly different chemical ratios. Webb's infrared readings emphasize carbon dioxide. Swift's ultraviolet data shows faint signs of water. Ground-based telescopes add dust profiles that don't always agree. The inconsistencies are partly real. Comets are dynamic, changing from day to day, and partly the product of limited sensitivity. The frustrating part is knowing that the moment you think you understand it, the comet changes or slips out of sight altogether. Distance is the final obstacle. Atlas never comes closer than 1.8 astronomical units, or about 270 million kilometers. At that range, even Hubble can't see the nucleus directly. No spacecraft has been dispatched for a flyby. Suggestions to redirect missions like Juno or New Horizons are fascinating, but logistically impossible. By the time proposals are drafted, Atlas is already too far. We're left with remote sensing, valuable but limited. These limits mean we'll always live with uncertainty. Was Atlas fragmenting as it passed? Did its surface chemistry evolve under solar heating? How typical is it compared to other interstellar objects? We may never know for sure, but uncertainty doesn't make the effort meaningless. In science, fragments of truth are still truth. Perhaps the scarcity of data even adds to the beauty. Every spectrum, every faint image becomes precious. Teams across the globe coordinate like never before, racing against time and physics to capture what they can. There's something almost poetic in that urgency. Humans scattered across the earth, united by the fleeting glow of a visitor that will never return. In the end, the limits of observation remind us that science isn't about complete certainty. It's about glimpses, small windows into vast mysteries. Atlas may not reveal every secret, but the secrets it does reveal will stay with us long after the comet itself has faded into the dark. Every detail we've explored, its chemistry, its orbit, its scale, leads us here. The realization that 3I Atlas is not just another comet, but a messenger from a time before our solar system existed. That thought alone is staggering. Imagine standing outside one night, looking up, and realizing that faint blur through a telescope has been wandering the galaxy for billions of years, waiting for this exact moment to cross paths with us. Numbers like 7 billion years or 11 billion years are easy to say, but almost impossible to comprehend. They're so vast that the mind blurs them into abstractions, yet comparisons help. Our sun is about 4.6 billion years old. Earth, a little younger. Life here, just 3.8 billion years. Human history, barely a sliver, maybe 10,000 years of civilization, 300,000 of our species. Against those numbers, Atlas is ancient beyond imagination. It was already old before our oceans formed. It was already ancient when trilobites crawled on the seafloor. It was older still when dinosaurs ruled the continents. To call it old feels almost like understatement. And yet, despite its immense age, our encounter with Atlas is fleeting. A few months of visibility, a handful of spectra and images, and then it will vanish forever. By early 2026, it will be beyond reach, accelerating back into interstellar space at nearly 60 kilometers per second. In archives, it will survive as data tables, graphs, and scientific papers. For the rest of human history, no one will ever see it again. This is our only chance. One meeting, one hello, and then silence. There's a bittersweet poetry in that. It reminds us that not all wonders are permanent. Some arrive only briefly, and their value lies in their very transience. A comet like Atlas teaches us to pay attention, to marvel, even when we know we cannot keep. Think of it like a lantern floating down a river at night. You see it approach, glowing faintly, you watch it drift by, and then it disappears downstream into darkness. You cannot hold it. You can only notice, reflect, and let it go. Atlas is that lantern, except its river's the Milky Way, and it has been floating for billions of years. What makes this climax so moving is the coincidence of timing. Of all the epochs in galactic history, it passed by just now, just when we have telescopes and minds capable of understanding what it is. 10 million years earlier or later, and we would have missed it entirely. In the vastness of time, we are here at the right moment. That coincidence alone feels profound. And perhaps that's the real lesson. Our lives are short, fragile, sometimes overwhelming. But for one brief moment, we were alive at the same time as Atlas. We noticed it, we measured it, we wondered about it. That connection between a human glance and a comet older than our world might be the most beautiful thing Atlas has to offer. So let this be the emotional crest of its story. Not fear, not threat, but awe. The kind of awe that quiets the mind and stretches the imagination. Atlas will not return, but the way it made us feel, the perspective it gave us, will linger long after it slips into the dark. When Atlas finally fades into the darkness, what will we have left? Not the comet itself. It will be gone, racing away into interstellar space. What remains are fragments, spectra, images, orbital tracks, countless hours of data stored on hard drives and in notebooks. To some, that might seem incomplete, even unsatisfying. We will never know the exact shape of the nucleus. We may never agree on the amount of water it carried. We cannot point to a specific star and say, that was its birthplace. In the end, much about Atlas will remain hidden. But maybe that is not failure. Science is not about having every answer neatly tied up. It is about glimpses. Each observation is a window, small but precious, into something greater than ourselves. Atlas has already given us more than we expected. It proved that comets can be wildly different from those we know. It showed us chemistry that doesn't fit the usual pattern. It hinted at formation environments far from anything familiar. Even in uncertainty, it has expanded our view of what is possible. Equally important is what Atlas revealed about us. Within days of its discovery, observatories across the globe, North and South America, Europe, Asia, coordinated in a way that would have been unthinkable a century ago. Data flowed from giant observatories to amateur telescopes, from Earth's surface to satellites in orbit. Scientists spoke across languages and time zones, united by a single faint dot of light. That cooperation is an achievement in itself, a quiet victory for human curiosity. There is a deeper lesson too. Atlas reminds us that we live in a galaxy full of wanderers. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. 3 objects in less than a decade. That pattern suggests there are countless others drifting invisibly through the dark. The more we learn, the more we realize our solar system is not isolated. It is part of a cosmic crossroads, where fragments of other worlds occasionally pass through. Recognizing that changes how we see ourselves, not as an exception, but as one piece of a larger galactic story. And perhaps that is Atlas's greatest gift. Not the data tables or orbital models, but perspective. It forces us to see time not in centuries, but in billions of years. Distance not in miles, but in light years. It shows us that we are brief and fragile, but also capable of noticing, of wondering, of reaching across the void with instruments and imagination. That is no small thing. So yes, Atlas will leave us with unanswered questions, but it will also leave us with wonder. And wonder, in the end, is the seed of discovery. We don't need perfect knowledge to be changed by the encounter. We only need to have noticed, to have looked up at the right moment and said, here is something older than our world, passing through our sky. And so, our time with 3i Atlas draws to a close. The comet itself will keep moving long after we finish talking about it here. It will drift past the sun, vanish into the darkness, and continue its journey through the galaxy, just as it has for billions of years. But for us, the encounter leaves something behind, a reminder, a perspective, a moment of wonder. Atlas shows us that the universe is older, stranger, and more patient than we can imagine. It reminds us that even small fragments of rock and ice can carry the memory of entire epochs, outlasting stars, planets, and civilizations. It also reminds us that our own story, though brief, is part of this larger tapestry. We may not last billions of years, but for a short while, we get to look up and notice. That's not nothing. That's extraordinary. When you think about it, the real gift of Atlas isn't just scientific data, it's the sense of connection it creates. Connection to deep time, to places we'll never see, to processes that shaped the galaxy long before we arrived. For a few months, as telescopes track a faint smudge of light across the sky, we are linked to that vast story. And even when Atlas is gone, the memory of that link remains. So tonight, as you settle down and let your thoughts drift, remember this. Somewhere out there, an ancient traveler is still moving. It doesn't hurry. It doesn't worry. It simply drifts through the stars, carrying the history of another world in its frozen heart. And for one brief moment in the life of the universe, it passed by us. Sleep well with that thought. Let it remind you that while our lives may be short and fragile, we are part of something immense and beautiful. The galaxy is full of travelers, full of stories, and every once in a while, one of them pauses just long enough for us to say hello. Good night.